Hello everyone and welcome. Today we're going to talk about networking in Android. Now that's a very broad title. To be more specific, what we're going to talk about is how to consume a RESTful web service. So we're not really interested in other networking stuff like how to set up Wi-Fi Direct, how to set up Bluetooth, how to set up sockets, Firebase cloud messaging or whatever. We're just interested in how to consume a RESTful web service in our Android applications. The agenda is as follows. We're going to start out with a recap of local data storage. After that, we're going to give you a primer on web services. So that's just some of the terminologies which you should know about already, but just to make sure that everyone is on the same page here. After that, we're going to look at the specific implementation in Android. There's a library called Retrofit we can use to communicate with web services. So we're going to learn how to use that. And after that, of course, there's a lot of exercises for you to toy around with. So that's the agenda. Let's get started. Local data storage. We talked about that last class, and you actually learned quite a few ways to persist data on the Android device. The first one being the simple one, share preferences, which was a class you could use to store key value pairs in an XML file on your device. So if you just wanted a bit of data saved, then that's the very easy and fast way to do it. But if you had more related and structured data, then you wanted to use a database instead. And for that we had SQLite, right? And we learned how to use the room persistence library, which was basically just an abstract layer on top of SQLite. And then you also learned how to use this room persistence library in conjunction with the MVVM architecture and the repository pattern. And the reason that was very powerful was that we could actually observe when anything changed in our database by observing live data. It was basically compatible with the room library. And then you also learned that this is often something that can take some time to do some CRUD operations on a database. So we had to do it on a background thread on another thread, not the main UI thread. And for that we learned about the asynchronous task, which we could use to basically do stuff in the background, right? And then after that return to the main UI thread again. And then some of you also toyed around with the settings menu as a bonus exercise, where you learned how to implement that, since a settings menu actually uses share preferences under the hood. But that was basically pretty much everything you learned. And then for the room persistence library, you also learned that it was pretty straightforward. You just had to implement this data access object as an interface or an abstract class, where you gave it the actual operations you wanted to be able to execute on the database as annotations, right? And then it pretty much just worked. And you'll see today that there's actually some similarities in what we're going to do with the Retrofit library. So that's a good thing, I guess. Okay, so on to today's topic, which is how to consume RESTful web services. So first and foremost, what is a web service, right? And I guess you know already, it's basically we have a client, and that client can send a request to some server, some computer on the internet, and they will give you back a response. And it doesn't have to be REST, that could also be SOAP or whatever. And I have an example right here. I have an Android application right here. It's a Pokemon application, of course, where you can enter a Pokemon name up here, for instance Pikachu, and then request an image for that Pokemon. And you can see we have a Pikachu here. And we can pretty much do that for all Pokemon. So we could also do it for Mew, or we could do it for Squirtle. Yeah, and you can see we're pretty much just the client right here, and we are sending a request. And with that request, we have this little Squirtle thing right here. And whenever we're requesting it, we're basically getting a response back with that image, right? So that's the idea of a web service. But often when you hear web service, you actually don't just hear web service, you hear RESTful web service or REST API. And that's also something you should know about already. And it's actually not super important when you're talking about consuming a web service. It's more important when you're building your own web service. But a REST API or RESTful web service basically just stands for representational state transfer. And it's basically just a way to structure your web services. So it's like a convention for how to model them. So it's not really a protocol in and of itself. It actually uses the HTTP protocol under the hood. And you can see right here, that's basically the most important thing of it, the most important takeaway, because then we have to use all of our CRUD commands with HTTP, so you know your good old get, put, delete, and post requests. And it works as client server, right? And some of the main ideas behind REST is basically that it's stateless. So that means every time you do a GET request to the service, for instance, then you expect it to give you the same output afterwards, because it doesn't hold any state about the request the client makes. And there are some other things that are interesting, like for instance, it's often JSON data that's sent back to you. So we're going to look at how to handle that today. But if you want to learn more about this, you can always just look at the thesis, which actually was what created this RESTful thing in the first place. Yeah, so I'm not going to go into detail with it, just know that it's the HTTP protocol, and we're going to handle some JSON data. Okay, so this HTTP protocol, or Hypertext Transfer Protocol as it's called, is actually shown here in the picture, right? So it's more or less like the one you just saw before, but now you can see, oh, this is a GET request, and the server is sending back another response here, and it has a status message with a code called 200, and that's basically the same as, oh, everything went okay, right? But it might also be that the client actually sends a post request and he is actually not authorized to get that data. Then you would get a status message like this instead. But this only shows like very superficial what happens. So what is actually interesting here is what happens in the request and the response, right? And you can look at it as a message, as an envelope almost, where you have a header and you have a body. So the response here is, the header is all of the metadata. So for instance, your status code here. You can see various status codes here. If the page was not found, it's 404. If everything went okay, it's 200, right? But that's all of the metadata that goes up in here in the header. And then down in the body you have the actual message that wants to be sent. So if you're basically contacting a website, then that will be the HTML for the actual website, right? Okay. And in order to access any of the data, you need an endpoint. And yeah, pretty much as when you go into the browser and enter a website, that's an endpoint, right? So it consists of the protocol here, that's the HTTP protocol, or HTTPS. And then you have the domain that you're going to access. And after that, the resource path. So that's basically just separated here by slashes, all the way up till the question mark here. And that's where the query actually starts. So just like with methods have arguments, then you can send along queries with your endpoint here. So that's the question mark, and then you can see in this case, I guess we're looking at some primates, and there are some specific attributes to those primates. It has to be the one who eat meat and are active at night. And then yeah, how does that work? So I could show you an example here from the one I used for the Pokemon one. So this is a Pokemon API where you can query it by going to this website right here. I already have it up here, so if I press enter, you can see I'm just given a lot of data about this Ditto Pokemon right here. So in here somewhere I'll find the image, and I'll find the Pokemon number and its abilities and all these kind of things. And you can see if I inspect this thing right here, and I go to networking, you can see it basically made a GET request right here. And I can click this here, and you can see here is the actual response. So that's the same thing as you look at over here, but you can also see the header information right here. So that's basically all of the metadata. So this is basically also just a normal HTTP GET request that we are dealing with here, with responses and requests, headers, and everything. So that shouldn't be new to you. You should know how this works, and you should know that this is just JSON data that is not formatted very nicely for us to look at right now. But that's totally fine. We're going to process that later. Okay. So there's a lot of APIs to choose from when you're doing this. I just listed some examples right here. You might want to toy around with the Facebook Graph API to get some data from Facebook. You can try out the Pokemon one as I just showed you. That's open and free. There's also an IMDb clone that is more easily accessible. There's some Spotify stuff. You can even get data from Wikipedia or data about cats or dogs. And down here I have a long list of APIs you can basically browse through and see if there's anything that you think fits your project needs. And there's also open data that's actually very interesting. That's for Danish data. I know this is also in Danish, so that's a bit unfortunate. But you can go in here and you can look at all sorts of data from, for instance, Aarhus right here. There's parking spots in Aarhus. You can get some JSON data about that. So there's a lot of interesting things here that you can take and use for free. Okay. What these things have in common here, or actually what some of them don't have in common, is how they're actually restricted. So some of these are more restricted than others. And when we're dealing with web APIs, there's basically 3 common authentication methods that you have to take into account. Some of them don't require authentication at all, like for instance the Poke API I use right here. You can just type in whatever request you want and then you can get the data back. There's no restrictions on it. But some of the others, like the Facebook one here, has restrictions. Spotify has restrictions, and even these 2 cat and dog APIs have restrictions. And they have different kinds of restrictions. So there is the basic HTTP authentication here. That's one way to restrict your data. That's basically just you're asking the user to log in with a username and a password, and then once he's logged in, you basically have access to everything. Okay, everything that user has access to at least. And then we have the API key restrictions. That's basically like the cat and the dog one right here, and also the OMDB API. They use an API key as restriction. So that basically means you have to go onto the website, register as a developer, and then they will give you an API key, which you need to send along with your HTTP requests. Okay, so they can identify that it's actually you who made the request. So that's a very common way to restrict access and consumption of a web service. Another newer one is what's called OAuth, and that's what Facebook and some of the larger sites are using. And that's because it's not only authentication, it is also authorization. So it's not only who are you, it's also what are you allowed to do. And how that works is basically you try to prevent what is happening here on the first basic authentication method, where the user basically enters the username and password. With OAuth, you're basically trying to do that in another place. Okay, so for instance with Facebook, if your application is going to use some data from Facebook, you're going to redirect the user to Facebook, where they authorize whatever you're going to do, and they're also logging in. Okay, so you're basically trying to not sign in directly from your application, but at some third-party authentication server. And this helps out with stuff like the user can basically restrict how much access your application get. Yeah, and that's very used not only on Facebook but also other social media sites like Instagram. Also on GitHub they have OAuth established. So that's pretty powerful if you only want to. If the user doesn't want to enter his email and password to give full control in an application, of course, he'll just be redirected, and whenever he gets back from that server, you will be given an OAuth token you can use to access some of the data from, for instance, Facebook. Okay, so these are pretty important, and sometimes if you pick an API that's more advanced like the Spotify or the Facebook one, and then you're going to need to sign up and register for their OAuth system and figure out how it works. And it's a few additional steps, but it's not that difficult, and I have some videos in the end to show you how that works as well. Okay. In order to do a request here and also manipulate the data we get back, we need to understand JSON, because most of the time it is the format that you're going to be given the data in. And it's basically just a lightweight data exchange format that is easy to read and also write for that matter. And although it's called JavaScript object notation, it doesn't really have anything to do with JavaScript per se. It can be used in any languages really, and we're using it in Java right here. That's totally fine. It's just very easy, as you can see here, to read. And this is the data types you have. So you have the curly brackets that signify an object. So you can see right here we have one object here. I guess that's of a person because there's a first name, there's an age, and all these kind of things. And you can have arrays as these brackets right here, and you can have numbers, and you can have strings and booleans and these kind of things. So you can see right here, for instance, the address, that's an object. And then we have down here on the square brackets there is a phone number, so that's basically an array of objects, right? So it's pretty straightforward. You can read this. It's quite hard to read though if you just look at the data and it's not formatted like this. But the computer can read it just as fine, so that's perfect. And normally you would have to actually convert this JSON data into objects, into Java objects, or into data structures. And that is actually sometimes time consuming. So what we can do instead is we can use this thing here called JSON, which is a library developed by Google that basically serializes and deserializes JavaScript object notation. So it deserializes and serializes the JSON data for us. And that's actually what you see right here, right? We can have some JSON and then we can convert that directly into objects if you just give it the appropriate classes so it knows how to map it. Okay. One thing I also briefly want to mention that you should be aware of and you should know already is how to use already existing web API testing clients such as Postman or Insomnia. And that's actually what you're seeing right here. So that's very good to test if a web API is working or not. So I know you can just go into the browser and do some quick endpoint testing. But if you want to use OAuth or you want to put in some additional information in the header or whatever, then you need either Postman or Insomnia for that. And also, sometimes it might be hard for you to find the perfect web service to consume and use in your projects. Then it's perfectly fine to go in and mock your own web service. So you can see right here there's this nifty little site here called Mocky where you can do that. But you can also do some of the same things in Postman if you want to do that. Or if you want to, you can of course set up your own web service. That's also an option. Okay. So let's talk about retrofit and let's talk about networking in Android. So if you go back a few years, there was not very many options in order to do networking in Android. You basically were stuck with this thing called HTTP URL connection. That was a class, an abstract class that you had to build on top of. And that basically was a time where you had to do all of the low-level Java connections yourself. You had to do all of the threading. You had to do all of the management of the streams of bytes. You had to do all of the parsing of JSON yourself and all these things. And now we're actually at a place where we have some libraries which are some abstract layers on top of these layers here. For instance, Volley, which is meant for general networking to make that easier, but also Retrofit here, which we're going to use today, which is basically just to make any communication with RESTful web services a lot easier. And it's actually built on top of this networking layer right here. Now you can see both the HTTP URL connection class and the OK HTTP. Actually, moving from Android KitKat and forward, it's only OK HTTP that's been used. So that's even what this is using under the hood. But that's not really relevant. What's relevant today is just that you know that Retrofit is here to make your life easier. It's an abstract layer on top of the networking layer that makes it easy to make RESTful web services and access them. So what we're going to do today is we're going to solve the last piece of the puzzle here of our architecture as we've been working on for the last few classes. We're going to make the repository able to get some remote data from a web service using Retrofit. And if you go to Square's website, the developers of Retrofit, they basically describe Retrofit as a type-safe HTTP client library for Android and Java, that is. So it's actually also possible to use this library in your normal Java applications. You don't have to do it only in your Android application. So that's very nice. And it makes everything faster and easier. You basically just describe how the endpoint should look and what you expect back, and that's it. And the way that works is actually pretty similar to how Room worked last class. So you know that you could basically just specify a Java interface, and then that described how you can communicate with the database. The same thing goes here. You basically create a Java interface, and that describes how you communicate with the HTTP API, the web service. And it supports asynchronous operations. So that means last class we tried to do a lot with the asynchronous task, and we had to set these things up manually to do background work. We don't have to here. Everything is taken care of. We're basically just getting the data back in a callback on the main thread. So that's very easy and convenient. And it also works right out of the box with converters such as JSON. Okay, so let's see here. This is basically a 6-step process to how to implement Retrofit. And yeah, the next slide's a bit pretty much just a monkey see, monkey do, step-by-step tutorial on how to get this up and running. So let's just get going. So you can see here, the example we're going to use is that exact Pokemon thing that I just showed you here. I also have made that available on GitHub, so you can see the code for it if you want to have a look at it and see it running. And then let's just get started, I guess. First things first, in order to use Retrofit, we need to import it, right? So we need to include it in our Gradle dependencies here. And you can see the two important ones for that are right here. We have our Retrofit library right here, and then we have the JSON library right here. So they have their own version of that as well available to you, so you can use JSON with it. And then these two down here, they are one here is for architecture using MVVM, as you know from last class. And then Glide is an image loading library, which we can also use because Retrofit can do that on its own. Okay, next thing is go into the manifest, make sure you have the permissions to actually use the internet. So you have to specify that in the manifest. And then now comes the interesting part here. So we want to specify how we can actually communicate with our web API. So what is possible to do with our web API on a very abstract level. So you can see right here, basically this Pokemon API, what you can do with that is basically this method right here. You can get Pokemon. So you can see this is just an interface. We don't have to create the class that implements this interface. That is done by Retrofit, just the same way as Room did it last week. So the only thing we have to say is our Pokemon API, our web service, is able to retrieve Pokemon. The only thing you have to do is give it a name, and then it works. And you can see the way that Retrofit understands this is that you tell it this is a GET request with this annotation right here. And then you specify the endpoint here, the resource path here, and then any attributes here or any queries you can also append to it if you wanted to. Notice here that these curly brackets are here and then it says name. That's because we have this annotation down here called path. So you can basically extend the path, you can extend the endpoint with any of these arguments down here in the method here. So that basically means we can get a Pokemon and then we can specify a name, and that will be an extension of this resource path right here. So whatever you write here will go up here. Also notice what we expect back from this get call right here. We expect basically a call object that has this Pokemon response inside of it. So the Pokemon response, I guess, would make sense, right? We get back some Pokemon data, right? But this call object is actually what is used to call and do stuff asynchronous on, but we'll get back to that in just a second. First, let's just look at how JSON actually works in order to automatically map our data into our data structures or into our plain old Java objects. It can map them directly into fields. So you can see this is the Pokemon response. This is actually what we expected back. And this is the actual JSON data which we got back right here. And then your objective here is to basically look at your JSON data and figure out how it's structured, what are objects, what are not objects, and try to map the data you want. So in my case, I didn't want all of this data right here. I only wanted a few things. I wanted the ID, the name, and the sprites. So the ID, that's right here, and the name is right here, right? So if you just specify the same name in your fields, then it can automatically convert these things into Java objects, or data structures, that is. So that's very handy. But if you want to specify another name for your fields, then you can just add the @serialized name attribute here on the top of the annotation right here, and then it will work with that name instead. And another thing here to point out is that this sprites class right here, it doesn't matter what you call the class, what matters is what the field is called up here. But notice here that that is actually an object, and that's why I have this inner class right here to signify that it's actually this object here where we are interested in this front default. Where is it? Right here, this front default URL right here. And then basically for the response, you can create your own get method where you can return in this case a Pokemon object, right, with all of the data we extracted from this response right here. Okay. And the next step, well, just to make things a bit cleaner, I've created a class that basically is responsible for generating this service, so generating the web API using Retrofit. So you can see this is just a singleton, just for simplicity's sake. Of course, in your own applications you could use dependency injection if you wanted to. But you can see right here, we're using the builder pattern here to create our Retrofit instance right here. And this Retrofit instance here was basically fed with the endpoint, the start of the endpoint here, the domain name, and then also whatever converter. So in this case, the JSON converter, which we're going to use to convert our JSON data into Java objects. Okay, and then you can see right here that it can then create our Pokemon API from that interface that we actually specified earlier. And then after that, I basically just have a method to get that Pokemon API so we can use it to do some requests. And that is pretty much the meat of it all here. Now we have our Pokemon API up and running and we can use it, and that's exactly what we're doing right here. So you can see here we have a method called request Pokemon that could be put inside of your repository or in its own API, Pokemon API client class, of course. But you can see we're using the service generator to get the Pokemon API. And then when we have the Pokemon API, we can use any of the methods we specified in the interface. So in this case here, we only had the get Pokemon method, which took in the Pokemon name. And then it returned, as you saw in the interface, a call object here that held the Pokemon response. And the reason it does this is because you can call methods on this call object. You can call either enqueue or execute. And as you can see over here, enqueue happens asynchronously and execute happens synchronously. Most of the time you just want to do this asynchronously. So that means, and this is very important because I see a lot of students making mistakes here and don't understand why the code is not working. This here is a callback. Whenever you're enqueuing, this happens asynchronously on another thread. So that means your code is executed here and then it just continues. And at some point in time, whenever the web service is back with a response, this on response would be called. Okay, so it doesn't happen like ding 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 line by line. This is a callback that happens later on. So you can never know for sure that this code here is called before the next code you have elsewhere in your code, right? This is very important, and the way you handle this, the way you should handle this is whenever you enqueue something here to happen on another thread and you receive the callback here, you should notify whatever you want to notify by using live data. So basically an observable. You can see in this case we just have a Pokemon object here where we are setting this is live data, so we're setting the value on it. You can see it's not post value because this response here is not on another thread, it's actually on the main thread. So it's only this enqueue here that happens on another thread. But basically, you receive the response from the web service, and you can then, with the response, do whatever you want. In this case, I just checked if the response actually had a code of 200. That's if everything went okay. I also think there's some other methods you can use, just response does is okay or something like that. I can't remember, but this is also fine. And then you can basically just extract in the body, so that's the primary response from the web service, and then that's a response where we had the get Pokemon method we created earlier from the Pokemon response class. And then also, if everything didn't went okay, then you have this on failure here that would be called, so you can go in and check if that is actually called as well, if you set something up wrong, or if the endpoint is not correct or whatever. But that's pretty much it. This is the meat of it. You can consume your web API whenever you have your interface and your service generator up and running. The way you do it is by calling enqueue to make it happen asynchronously, and that basically gives you a callback that is called whenever the service is ready with a response. And in here, then you can basically use live data to notify any observers about the data changes from the web API here that you got. Okay. One last notice here. One thing I want to point out is that these images here are actually not loaded in using Retrofit. I'm using an image loading library called Glide. There's a lot of other fancy image loading libraries you can look at, but I think Glide is just fine. There's also one called Picasa, and Wally can also do it. But yeah, try one of them out and see how it works. You can see it's pretty simple, just one line, and then you can load whatever data you want. And also, I'm not going to show you any live coding today. I'm going to keep it simple because I found this very nice video tutorial here on YouTube with a guy that goes through using Retrofit step by step, how to do get requests, put requests, even how to do OAuth and handle that if you want to use some of those web APIs. And he also goes in depth with JSON if you want to get to know more about how to use that. But as you can see here, Retrofit takes care of most of it as long as we just create the correct classes with the correct fields, and then we'll automatically map everything. Yeah, and yeah, that's pretty much it. This week's exercises, as you can see right here, is pretty much just a step-by-step of what I went through here. Find some web service you want to work with. There's some nice ones here, even some food for fork here for some food data, and yeah, there's all sorts of stuff. And you saw the list earlier also on the slides. And then this just setting up Retrofit step by step, how to use the service generator class, how to set up the JSON thing so that works, how to test your requests, and how to make everything work in conjunction with the MVVM architecture and the repository pattern, which we talked about in the previous weeks. And then as a bonus, there's also some things here you can look into. But that's pretty much it. Thanks for watching, and see you soon.